we will start to chapter second, which is the differentiation chapter, okay? And for this chapter, let's sketch a graph which is related differentiation, okay? And this is our C curve, okay? And when you draw a straight line which meets at the P point on the C curve, and this line is L line, and this is C curve, okay? And also it can be obtained from the f of x function, okay? And what did I say? This is the P point, which is x0 comma y0. And also, for simplicity and to avoid certain problems and the best postpone until later, we will not deal with the most general kinds of curves now, okay? But only with those that are the graphs of continuous functions, okay? And the let C curve in here is the y of f, y equals to f of x functions, okay? And as you see, this point is P, okay, and which is the intersection point of the L line and the C curve, okay? And what do we mean when we say that the line L is tangent to the C at the P point? As you see, this is the tangent point, and we know that our past experience with tangent lines to circles does not help us to define tangency for more general curves, okay? And now, as you see, we can say this point meets the circle at only one point, or the circle lies on only one side of the line, or another saying is the tangent is perpendicular to the line joining the center of the circle to the point of contact, okay? And that means this is not only one curve, okay? If you say, yes, I have a point, okay, like that, for example, okay, and you have a line, for example, this is your curve again, okay, and the L line can be like that lines, okay? As you see, you can evaluate, oops, last one isn't correct. You can evaluate lots of the L line, okay? As you see, all of them can be L line, and this is P and this is C, and but the and this was the this is C curve, okay, and this point is Q, and also this is x0, okay, y0, and this point is x0 plus h, okay. And now we can define the Newton coefficient about these tangency lines, okay, and it will be, okay, f of x0 plus h minus f of x0 over h this is Newton quotient, right? Or you can call this difference quotient, okay? And let me give you non-vertical tangent lines definition. Okay. Suppose that f is continuous, okay, at the x equals to x0 point, okay, and here is suppose that, okay, and the limit h approaches 0, f of x0 plus h minus f of x0 over h, it equals to m exist, okay, and we will call this m point, okay, tangent, okay, and this is the slope of the tangent, of course, and y equals to m times x minus x0 plus y0, okay. This is the tangent. That means the straight line, which was the L line, okay, having slope m point and passing through the point P point, okay, which was the x0 comma f of x0, and it will be called the tangent line, okay, or the tangent, okay, and it is the tangent to the graph of y, okay. So, and this equation can be obtained easily, okay, which is tangent equation. Let me continue with some examples. Okay. Y equals to x squared at point 1 comma 1, okay, and let's find an equation of the tangent line f of x equals to x squared, x0 equals to 1, y0 equals to 1, okay. So firstly we must evaluate the m point, okay, and the m equals to limit h approach to 0, okay, f of x0 is 1 plus h minus f of x0, which was 1 over h. So limit h approach to 0, okay, and the 1 plus h squared minus 1 over h. Limit h equals to 0, okay, and it's the 1 plus 2h plus h square minus 1 over h, and this ones will be cancelled, and after that limit h equals to 0 and h parenthesis 2 plus h over h, and also this h will be cancelled, and after that you will obtain 2 point, okay, I'm sorry, which is r endpoint, okay, because it's r slope. And the tangent equation says us y equals to m times x minus x0 plus y0, okay, and the y equals to 2 times x minus 1 plus 1, okay, and when you simplify it you will obtain 2x minus 1, okay, and which is our tangent line equation, okay, and you can write this the equation of the tangent line to the curve y equals x squared at the point one comma one. And now let's talk about another function, which is the x to the power of 2 over 3, okay. Okay, and let's x0 equals to 0, of course y0 will be 0, and find the tangent equation or tangent equation at the origin, okay. Let's talk about it, and formally m equals to, okay, f of 0 plus h minus f of 0 over h, and it's equal to h to the power of 2 over 3, okay, over h, and also it's equal to 1 over h to the power of 1 over 3, okay, and of course here will be limit h equals to 0, okay, and for this, okay, as you see, it will be infinity. So to understand this curve or this tangent point, okay, maybe we will try to sketch our graph, okay, at this point. Okay, our graph will be like that, okay. Okay, and at this point, okay, you can't sketch any tangent line, okay, and here is a problematic, okay, and we will say at this point, okay, cusp at the origin. Okay. And the totally result, we will say, has no tangent at the origin. Okay. And another famous example about the tangent problem is absolute value function. Let's remember and sketch this curve, this line, absolute value graph, and it was like that, I think, right? And this is y equals absolute value of x, right? And does the graph of y equals absolute value of x have a tangent line at the origin? Okay. Let's remember our function, limit function, 0 plus h minus 0 over h is equal to absolute value of h over h. Okay, and this is the special function, which is the signum h function. Okay, and it equals to plus 1 if h larger than 0, and it's minus 1 if h is less than 0. Okay, so we can say this graph has no tangent line at the origin again. The slope of a curve okay the slope of a curve C at a point P is the slope of the tangent line to C at the P if such a tangent line exists, and in particular the slope of the graph of y equals to f of x at the point x0 will be limit h approaches to 0, okay, f of x0 plus h minus f of x0 over h. Okay, let me correct it again. Okay, and after that I want to give another definition about that. Normals, and the same definition if C curve has a tangent line at the L lines, okay, at the point P, okay, then the straight line N draw P perpendicular to L line is called the normal to see at the P point, okay? And if L is horizontal, then N is vertical, okay? If L is vertical, then N is horizontal. That means, let me sketch it, okay? For example, and okay, and these green lines are, okay, are slopes, okay? And these are the normals, okay? These are normal. This is our P point. I'm sorry. This is L, and this is C curve, L line, and this point is P, and this red line is normal, okay? And what can we say about the slope of the normal? We know that slope of the normal equals to -1 over slope of the tangent, okay, which is the L line, of course. Okay, now let's do an example. Y equals x squared at the 1, 1 point, okay, and find the normal equation okay, and we know that from the previous example, slope of tangent was 2, okay? So slope of the normal equals -1 over slope of tangent line, which is 2, okay? And after that equation will be y equals to -1 over 2 slope of the normal times, okay, x minus x0, which is 1 plus 1, and when you simplify it, y equals to minus x over 2 plus 3 over 2. This is the normal equation of the x square curve at the point 1, 1. Okay. Example. find equations of the straight lines that are tangent and normal to the curve y equals square root of x, okay, at the point four comma 2. Okay, let's first to evaluate the slope of the tangent line, okay, and it was the m equals to limit h equals to 0, okay, square root of 4 plus h, okay, and the minus 2 over h, and it equals to limit h equals 0, okay, and the square root of 4 plus h minus 2, okay, times square root of, I'm sorry, square root of 4 plus h minus 2 times square root of 4 plus h plus 2 over h times square root of 4 plus h plus 2. Okay, and after that limit h equals infinity, and the 4 plus h minus 4 over h times square root of 4 plus h plus 2, right? And you can evaluate this part, okay, simplify it, and after that limit h equals to 0, okay, and 1 over square root of 4 plus h plus 2 is equal to 1 over, okay, 2 plus 2, and it's equal to 1 over 4. Okay, so m equals to 1 over 4. This is the slope of tangent, okay, and the y equals to 1 over 4 times, okay, and the x minus 4 plus 2, okay, this is the equation of tangent line. Okay, slope of the normal equals to minus 1 over slope of the tangent, which is 1 over 4. It equals to minus 4. So the equation of the normal line will be y equals to, okay, minus 4 times x minus 4 plus 2. Okay, this is the equation of the normal var.